Hello children. So today we will do exercise 6.2 question number 3, 4 and 5. I'm sure you must have practiced 1 and 2. Question number 2 we had done it in the last video. So today we will be doing 3 and 4, and without wasting any time, let us proceed. Okay. So the first question, that is the question number 3. In figure 6.18, if LM is parallel to CP, figure is already given. If LM is parallel to CP and LN is parallel to CD, then prove that AM by AB is equal to AN by AD. Okay, so now let us proceed. Okay, so solution. Okay, I think there is some problem. Solution. So it is telling that, okay, let us now take triangle ABC. Okay, so let me take in triangle ABC. What can I write in triangle ABC? As per the basic proportionality theorem, it is already given that LN is parallel to CP. You write LM is parallel to CP. It is given. Okay. If LM is parallel to CP, I can write AM by AB. I can write MB or I can write AB. Okay. AB is equal to AL by, see, if I would have written AM by MB, then here I would write AL by LC. But what I have written already, AM by AB will be equal to AL by AC. Okay, name it as equation number 1. And what is the reason? Reason is BPT. What is BPT? Basic proportionality theorem or the Thales theorem. Okay. Now, in triangle ACD, what do you know? LN is parallel to CD. LN is parallel to CD. So, if LN is parallel to CD, as per the first equation, what can we write over here? I can write AN by AD, because here I had written AM by AB. So I am writing AN by AD is equal to AL by AC. AC, again it is as per BPT, and name it as equation number 2. So from equation 1 and 2, what can I write? From equation 1 and 2, see, the RHS is equal. Here we have AM by AB is equal to AL by AC, and here I have AN by AD is equal to AL by AC. So both the RHS are equal, so LHS will be equal. So what I will write? I can write AM by AB is equal to AN by AD. Okay. Proved. Clear all of you? So this is your question number 3. Now in question number 3, What was the question? AM by AB should be equal to AN by AT. So we have already proved it. Okay, fine. Now let us go to question number 4. So what is question number 4? Question number 4 states that in figure 6.19, DE is parallel to AC and DF is parallel to AE. Prove that BF by FE is equal to BE by EC. Now some of you must be thinking, अरे बाप रे, ये तो क्या दे दिया क्वेश्चन, इसको कैसे सॉल्व किया जाए? Don't worry, it is also very simple. See, after it is being solved, you will say, अरे बाप, बस इतना ही था, इतना ही करना था इसमें. Okay, so in triangle, I will take A, B, C. A, B, C. What is given? DE is parallel to AC. DE is parallel to AC. Okay, fine. Now, if it is parallel to AC, then I can write BE by EC. See, BE by EC will be equal to BD by DA. Why? Basic proportionality theorem. Name it as equation number 1. Reason is basic proportionality theorem. Okay. Now we go to in triangle. What is the next triangle that we'll take? See, our next clue is it is given DF is parallel to AE. So let me take ABE triangle. ABE triangle. Okay. If I take in triangle ABE, what can I write? See, as per the figure, it is given DF is parallel to AE. So I can write BF or BE. चलो लिखते हैं, because I want to make this side. No, this side will not be equal. This one will be equal. Okay. So BE by FE. BE by FE will be equal to B here, BF. This is the mistake I have made. BF by FE is equal to BD by TA. Okay, again, what is the reason behind this? Basic proportionality theorem. Name it as equation number 2. So same way as the first question. From equation 1 and 2. See, the RHS is equal. So LHS will also be equal. BE by EC is equal to BF by FE. See, this is over. What was the question? This was the question, and now we have got this as the answer. Okay, so this is proved. Fine. Okay, now your question number 4 is also over. Now let us go to question number 5. In figure 6.20, DE is parallel to OQ and DF is parallel to OR. Show that EF is parallel to QR. Now if you see this figure, what do you feel? It looks like a 3D triangle, isn't it? Doesn't it look like a prism? So here you find that ED, PQO is one face of the prism, POR is the other face, and the front face is PQR. ED is parallel to OQ, DF is parallel to OR, and you have to prove that EF is parallel to QR. So now let us start the solution. Okay, solution. In triangle POQ, it is given that DE is parallel to OQ. Fine. So if this is the case, then what does that imply from the basic proportionality theorem or the Thales theorem? It tells us that PE by EQ is equal to PD by DO. Yes or no? PE by EQ is equal to PD by DO. Okay. Reason? BPT, basic proportionality theorem. Name it as equation number 1. Now let us go to the other face, POR triangle. So write, in triangle POR, what is given? DF is parallel to OR. DF is parallel to OR. Okay. If this is the case, then what do you have? You have PD by DO is equal to PF by FR. Yes or no? See, PD by DO is equal to PF by FR, because it is given that DF is parallel to OR. Again, what is the reason? Basic proportionality theorem, and name it as equation number 2. Okay. Now from equation 1 and 2, what can you say? From equation 1 and 2, we can say that PE by EQ. Why? Because PD by DO here in the right hand side, and in the second equation left hand side PD by DO, both are same. So definitely PE by EQ is equal to PF by FR. So PE by EQ is equal to PF by FR. Okay. So if this is the case, what you have learnt? If PF, see, if PE by EQ is equal to PF by FR. See once again, PE by EQ is equal to PF by FR, then you can very well say that EF is parallel to QR. So now let us write it. Okay, so you have got PE by EQ is equal to PF by PR. So you can say that, so EF is parallel to QR. Why? Reason is by converse of basic proportionality theorem. This is the reason. Okay, so now it is proved. Fine. So with this we finish question number 5, and this is all for today, and in my next video we will have the rest of the questions. So till then, bye and take care of yourself.